Please like and share my videos. Please subscribe if you have not already subscribed. 14 questions were given from the section Limits, Continuity and Differentiability from the chapter Differential Calculus in the JEE Main examination held in January 2024 session. In an earlier video, we have discussed the first 4 questions. We now discuss the next 4 questions in this video. This question has appeared in the 29th January 2024 in the second shift. The given question is, let f of x is equal to under the square root of limit r tends to x in brackets 2r square in brackets f of r whole square minus f of x into f of r bracket close whole by r square minus x square minus r cube e to the power of f of r by r bracket close be differentiable in the open interval minus infinity to 0 union the open interval 0 to infinity and f of 1 is equal to 1. Then the value of EA such that f of A is equal to 0 is equal to, we are given f of x like this, and it is given it is differentiable in the whole of the real numbered line except at the origin, except at x is equal to 0, and it is given f of 1 is equal to 1, required to find the value of EA when f of A is 0. Let's now discuss the solution of the problem in detail. We are given f of x like this. Agreed. Call this as the equation 1. Now, it is given f of x is differentiable on the whole of the real numbered line except at x is equal to 0. And the value of f at 1 is equal to 1. Let's now square this equation 1. So squaring, we get f of x whole square is equal to limit r tends to x in brackets the whole of the given expression. Right. Now what we do is we separate the terms. So limit r tends to x into 2r square into f of r. So from these, one f of r is taken common, 2r square f of r by r square minus x square, r plus x into r minus x, 1r plus x we will write here, and r minus x write in the next term. So that is f of x whole square is equal to limit r tends to x, 2 into r square into f of r is taken common by r plus x. And what is left is f of r minus f of x by r minus x, and limit r tends to x of that one, minus limit r tends to x of the second term, that is r cube into e to the power of f of r by r. Remember, x not equal to 0. Agreed. Now limit r tends to x of 2r square will be 2x square by x plus x, 2x into f of x. Why f of x? Now f of x is differentiable everywhere except at x is equal to 0. So it is continuous. It is continuous everywhere except at 0. So limit r tends to x of f of r will be f of x. x not equal to 0. Limit r tends to x of f of r minus f of x by r minus x is f prime r, f prime x, the derivative of f at x, minus limit r tends to x of r cube is x cube into e to the power of f of x by x. Remember, x not equal to 0. So we get this one, right? So now what 2x cancels and you are left with x into f of x. Write for f of x as y. Then f prime x will be dy by dx. Then this will be y square. This is f of x is y of x. Y square is equal to x. F of x is y into f prime x is dy by dx minus x cube into e to the power of y by x, where y is f of x. Let's continue in the next slide. We have this one, right? So what is this? It is a first order non-linear differential equation. Agreed. The presence of y by x in the power of e suggests us that you write everything in terms of y by x. To do so, you divide throughout by x square. Then y square by x square is equal to y by x, because you are dividing by x square, into dy by dx minus x cube by x square, x into e to the power of y by x. Good. Now this turns out to be in terms of y by x. Now put y by x is equal to v. Then y will be equal to vx. Differentiating both sides with respect to x, you will get dy by dx is equal to v plus x dv by dx. Substitute in the above equation. Then you will get v square is equal to y by x, v into dy by dx, v plus x dy by dx in brackets minus x into e to the power of v. Now multiply. This will be v square is equal to v square plus vx into dv by dx minus x e to the power of v. Cancel v square and rewrite the equation as vx into dv by dx is equal to x e to the power of v. Cancelling x on both sides. Remember, x not equal to 0. And that will give you v into dv by dx is equal to e to the power of v. And this can be written as v into e to the power of minus v into dv by dx is equal to 1. So variables are separated and you can write integrating on both sides. Integral of v e to the power of minus v dv is equal to integral of dx plus c, where c is the constant of integration. It is well known the integral of v e to the power of minus v dv is minus v plus 1 into e to the power of minus v. It is a well known formula. Integral of dx is x plus c, where what is v? V is y by x. What is y? Y is f of x by x. Right. Now this will become minus v f of x by x plus 1 into e to the power of minus v minus f of x by x is equal to x plus c. So that is what we have. And now put given f of 1 is equal to 1. So put x is equal to 1 in this equation. Then you will get this one. Now put f of 1 is equal to 1. Then it will be minus 1 plus 1 2 into e to the power of minus 1, that is minus 2 e to the power of minus 1 is equal to 1 plus c. That will give you the value of c as minus in brackets 1 plus 2 by e. Substitute the value of c in the equation, in this equation. Then you will get this. Now, required to find the value of EA when f of a is equal to 0. So, in the above equation, put x is equal to a and f of a equal to 0. So, substitute x is equal to a in the above, then you will get this. Then f of a is equal to 0, then you will get minus 1 into e to the power of 0, 1. So, minus 1 is equal to a minus 1 plus 2 by e in brackets. Minus 1 cancels and you will get a is equal to 2 by e and ae is equal to 2. That's what we want. So, that's the answer to this question. So, the answer to this question is ae is 2. Let's move to the next question. This question has appeared in the 30th January 2024 in the first shift. The given question is, if the function f of x is equal to 1 by mod x, when mod x greater than or equal to 2 and when mod x less than 2, f of x is given to be ax square plus 2b, and it is given f of x is differentiable on the whole of the real numbered line, then required to find the value of 48 times a plus b. Let's now discuss the solution of the problem in detail. We have f of x is given like this. So, mod x is greater than or equal to 2 is same as minus 2 less than x less than 2. Mod x less than 2 is same as mod 2 less than x less than 2. So, write down separately, and that will be equal to, for x less than or equal to minus 2, that means it is negative, mod x will be minus x minus 1 by x. In the interval mod x less than, in mod x less than 2, that is in the interval minus 2 less than x less than 2, it is ax square plus 2b. When x greater than or equal to 2, 1 by mod x will be 1 by x only because it is positive. So, 1 by x, x greater than or equal to 2. Right. Now, it is given that this function f of x is differentiable on R. Differentiability implies continuity. Therefore, f of x is continuous on the whole of the real numbered line. So, this function is continuous at x is equal to minus 2 also. We take that. So, f of x is continuous at x is equal to minus 2. When x is equal to minus 2, it is minus 1 by minus 2. And limit extends to minus 2 of ax square plus 2b. That means you are considering the right and left limits at x is equal to minus 2. Agreed. Then you will get this as 1 by 2 is equal to 4a plus 2b. That is our first equation. Keep it like that. Now, it is given f of x is differentiable on the whole of the real numbered line. Then the derivative of fx, that is f prime x, is equal to derivative of minus 1 by x is 1 by x square. The derivative of ax square plus 2b is 2ax. The derivative of 1 by x is minus 1 by x square in the same intervals, in the same domains. Agreed. Now, it is differentiable on the whole of the real number line. Therefore, it is also differentiable at x is equal to 2. So, f of x is differentiable at x is equal to 2. Then, the derivative f prime 2 plus, that is the right hand derivative at 2 is equal to left hand derivative at 2. So, f prime of 2 plus is 1 by 2 square. Is 2 plus means here, I am sorry, not here. So, 2 comes x greater than or equal to 2, that means it is here, minus 1 by 2 square into f prime 2 minus means from this side, that is 2a into 2, right. So, that means you will get the value of a as minus 1 by 16. Now, we got the value of a and we have a relation 4a plus 2b is equal to 1 by 2. Substitute the value of a, then you will get the value of b. So, you take that and substitute the value of a in this and simplify. You will get 2b is equal to 3 by 4, that is b is equal to 3 by 8. And now required to find the value of 48 times a plus b, that is 48 into the value of a minus 1 by 16 plus the value of b 3 by 8. Simplify, you will get 48 into 5 by 16, that is after cancellation you will get 5 3s are 15. Therefore, the answer to this question is 15. That is the detailed discussion of the solution of this problem. Let's move to the next question. This question has appeared in the 31st January 2024 examination held in shift 1. The given question is, let g of x be a linear function. That means g of x is of the form ax plus b, and f of x is given to be g of x when x less than or equal to 0. When x greater than 0, it is given to be 1 plus x by 2 plus x whole to the power of 1 by x. It is given that f of x is continuous at x is equal to 0, and if f prime 1 is equal to f of minus 1, then required to find the value of g of 3. You are given f prime 1 is equal to f of minus 1 and required to find the value of g of 3. Let's now discuss the solution of the problem in detail. We are given 4 options here. Given that g of x is a linear function, so we take g of x to be ax plus b, then f of x is equal to ax plus b. G of x when x less than or equal to 0 means ax plus b when x less than or equal to 0, when x greater than 0, the same function as it is. Agreed. It is given that f of x is continuous at x is equal to 0, then the left hand limit of f of x is equal to the right hand limit of f of x at x is equal to 0. And that will be limit extends to 0 of ax plus b. This is the left limit. Limit extends to 0 of 1 plus x by 2 plus x whole to the power of 1 by x. This is the right limit. Right. So this limit extends to 0, ax plus b is b only. because it is a polynomial. And limit extends to 0. Limit extends to 0. 1 plus x by 2 plus x to the power of 1 by x is 1 by 2 to the power of infinity. And 1 by 2 to the power of 1 by 2 to the power of infinity, that is 1 by 2 to the power of n tends to 0 as n tends to infinity. So it will be b is equal to 0. So when b is 0, g of x will be ax. So g of x is a into x. Then your function f of x will be ax when x less than or equal to 0, and when x greater than or equal to 0, the same function as it is. Agreed. Let's continue the discussion in the next slide. We have this function f of x like this, and we have g of x is ax. Agreed. Now we are given f prime 1 is equal to f of minus 1. This suggests us that we need to differentiate f of x. So that means we want f prime x. So f of x is, and when we want f prime at 1, 1 means greater than 0. That means we have to take that function when x greater than 0. So therefore we take f of x is equal to 1 plus x by 2 plus x all to the power of 1 by x, x greater than 0. Why we have taken this only? Because we want its derivative at x is equal to 1. Right. Now we differentiate. Right. F of x is this. We differentiate x greater than 0. Remember. So f prime x, to differentiate this one, take the logarithm on both sides. Logarithmic differentiation we do it. So ln of f of x is equal to 1 by x into in brackets ln of the numerator 1 plus x minus ln of the denominator 2 plus x. Now differentiate with respect to x. We'll get 1 by f of x into f prime x, and apply u by v formula. U by v formula. Then we have done here u by v formula we have done, and now substitute x is equal to 1. Then you will get 1 by f of 1 into f prime 1 is equal to 1 into in brackets 1 by 1 plus 1, 1 by 2 minus 1 by 3 minus in brackets ln of 1 plus 1, ln of 2 minus ln of 3 whole by x square, that is 1 square, that is 1. So f prime 1 is equal to f of 1 times, now simplify this one, you will get it, when you simplify this, 1 by 6 minus ln 2 minus ln 3 is ln of 2 by 3. What is the value of f of 1? So going to f of x when x greater than 0, substitute x is equal to 1. Then you will get 1 plus 1 by 2 plus 1, that is 2 by 3, by 1 by 1, that is 2 by 3. That is f of 1 is 2 by 3. Substitute here, you will get f prime 1 is equal to, f of 1 is 2 by 3 into 1 by 6 minus ln of 2 by 3. So get back to the discussion here. So f prime x we have already seen here, it is f prime 1 we have already seen here 2 by 3 into 1 by 6 minus ln of 2 by 3. Agreed. It is given f prime 1 is equal to f of minus 1. So given f prime 1 is equal to f of minus 1. If you want the value of f at x is equal to minus 1, you have to go here, that is when x less than or equal to 0. So minus 1 less than or equal to 0, there you substitute a into x, a into minus 1. So f prime 1 value as it is, it is equal to f of minus 1 is a into minus 1. So the value of a will be 2 by 3 into minus we have taken inside ln of 2 by 3 minus 1 by 6. Agreed. Agreed. What is that we want? G of 3. So G of x is ax. So G of 3 is 3a. And 3a means the above equation multiplied by 3. Then you will get 2 into ln of 2 by 3 minus 1 by 6. Multiply 2 ln of 2 by 3 minus 2 by 6, that is 1 by 3. 2 ln of 2 by 3 is ln of 2 by 3 whole square, that is ln of 4 by 9, minus 1 by 3 is written as ln of e to the power of 1 by 3. Then this will be ln of a minus ln of b is ln of a by b. That will be ln of 4 by 9 e to the power of 1 by 3. That is the value of G of 3. Let's look at our options. Yes, this tallies with option 4. Therefore, the answer to this question is option 4. So that is the detailed discussion of the solution of this problem. Let's now move to the next question. This question has appeared in the 31st January 2024 in the first shift. The given question is limit extends to 0 of e power 2 times mod sin x minus 2 times mod sin x minus 1 by x square. We are given 4 options. Right. Let's now discuss the solution of this problem in detail. So take limit extends to 0, whatever it is given here. Now multiply and divide by mod sin x whole square. So you have divided by mod sin x whole square and multiplied by mod sin x whole square is same as sin square x and this x square as it is. Now the limit of the product is equal to product of their limits. So the limit of the first minus into limit x tends to 0 of sin x by x whole square. And you know limit x tends to 0 of sin x by x is 1. So you will get limit x tends to 0 of e power 2 times mod sin x minus 2 times mod sin x minus 1 by mod sin x whole square. Right. Now put mod sin x as t. Mod sin x as t. Now as x tends to 0, mod sin x tends to 0, that means t tends to 0. So mod sin x is equal to t. As x tends to 0, t also tends to 0. Then the above will become limit t tends to 0 e to the power of 2t minus 2t minus 1 by t square. As t tends to 0, this takes 0 by 0 form, which is an indeterminate form. To evaluate this one, we use L'Hopital's rule. That is, differentiate numerator and the differentiate denominator, then take the limit. So the limit t tends to 0 of the derivative of the numerator is 2 e to the power of 2t minus 2 by 2t. Again, as t tends to 0, this takes the form of 0 by 0 form, which is an indeterminate form, and we use L'Hopital's rule to evaluate this one. So differentiate the numerator and the differentiate the denominator and take the limit. Limit t tends to 0, the derivative of the numerator is 4e to the power of 2t. The derivative of the denominator is 2. So 2 cancels. As t tends to 0, it will be 2. So the answer to this question is 2. That is and 2, and this answer 2 appears against option 4. So therefore the answer to this question is option 4. That is the detailed discussion of the solution of the problems. from the differential calculus and under the topic limits, continuity and differentiability. I am sure that you have understood the solutions of these 4 problems, and I wish you all the best. Thank you.